Hey, so this is the second part of our lesson on solving absolute value equations and inequalities, and we're going to jump in today beginning with the inequality part of it. So thinking about the inequality of an absolute value, this one says the absolute value of x is less than a. This means that the distance between x and 0, some value, some number, and 0, on the number line is fewer than a units. It's less than 8 units. So any value of x that is less than a units away from 0 makes the inequality true. So thinking about it this way, here is 0, and this is our value. It's so many units on this side of 0, and it's so many units on that side of 0. So when I think about it, there's the two cases. There's the expression inside the absolute value where it's not negative. And of course, there's the expression inside where the absolute value is negative. So we've got to look at both cases still yet with inequalities. So when I'm looking at inequalities, we got to think about the fact that we are making it negative. And what is our golden rule of inequality? So in case one, it's just the exact same. The absolute value of what's inside the absolute value is, or no, that didn't even make sense, did it? So what's inside of the absolute value is less than C. Or the second case where the absolute value in here could be negative, a negative number. So when I think about this part being negative, that's like dividing both sides of my inequality symbol by a -1. So when I do that, I know that the golden rule of inequality says if I divide both sides by a negative, I've got to flip the symbol. So when I look at the negative case, I have to flip my symbol around. So it's no longer less than, it ends up being greater than that negative value. So same thing happens if it started off with it being greater than. When I look at the negative side of things, or think of what could be on the opposite side of 0, then I have to flip the symbol around. And think about that. If I'm looking at this, if I'm saying a number is less than this many units away from 0, it's fewer than a units from 0. So it's somewhere in between here. Well, if I'm trying to show between a and 0, then I'm looking at the values greater than a. But if I'm looking at the values between this positive a and 0, I'm looking for the values that are less than a. So it makes sense that one's going to be greater than and one's going to be less than. Okay, so let's jump into it and look at some examples. Beginning with example 5, it says solve an absolute value inequality. We've got the absolute value of 4x minus 8 minus 5 is less than 11. So again, it's important to first isolate the absolute value. We always isolate first. Isolate, isolate, isolate. Then we make our two cases. So I've got to get rid of that minus 5. I do that by adding 5 to both sides of the inequality. So I end up with the absolute value of 4x minus 8 is less than 16. So now I can make my two cases where the 4x minus 8 is less than 16, or 4x minus 8 is greater than negative 16. We've got to flip that symbol because we changed the sign. So we've got our two cases. We know to add 8 to both sides. In both cases, we add 8 to both sides. Then we divide both sides by 4, and on this side we end up with x is less than 6. Over here we have x is greater than negative 2. Now we've got to check and make sure that it works. We plug it back in, and we say that x is less than 6, x is greater than negative 2. So this is the solution set, x such that x is in between -2 and 6. It's greater than -2 and it's less than 6. And remember, this was a less than. My redneck way of saying this, of remembering it, is I always say it's less than, it's an and problem, or greater, it's an or problem. So when I'm looking at absolute values, if it's less than, it's an and problem. And if when to begin with it's greater, it should be an or problem. So this is less than, and tells me that they're going towards each other. X has to meet two criteria. It has to be less than 6 and greater than -2 at the same time. So all of these numbers in between here meet both of those criteria. They're less than 6 and they're greater than -2. So they're in between there. Does that make sense? Like if I always give the example in Algebra 1, if I make my Christmas list and I ask for an Xbox and a PlayStation, I'm wanting both things. I'm a little bit selfish, aren't I? I'm asking for a lot to ask for the Xbox and the PlayStation. I'm expecting both to be under that Christmas tree when I wake up on Christmas morning. But if I say, Mom, Dad, let's be reasonable here. I don't need both. So I can't decide which one I want. So for Christmas, I want an Xbox or I want a PlayStation. I want this one to happen or I want that one to happen. I'm not expecting both criteria to be met at the same time. I'm not expecting to find that Xbox and the PlayStation. I'm expecting to find the Xbox or the PlayStation. So that's the difference between and or problems. And both things have to happen at the same time. Or problems, it can be this over here happening, or it could be this over here happening. It doesn't have to be the same thing. Okay, so looking at example 6, we're looking at greater problems. So these are the ors. We have the absolute value of 6x plus 3 all over 2 plus 5 is greater than or equal to 14. So first we know isolate, isolate, isolate. So I've got to get rid of that plus 5 by subtracting 5 from both sides. Then I've got to get rid of that divided by 2 by multiplying both sides by 2. So I end up with the absolute value of 6x plus 3 is greater than 18. So I've got case 1 or case 2 because it's greater. So case 1 is where 6x plus 3 is greater than or equal to 18. Or case 2 where 6x plus 3 is, I should switch my symbol because I'm making this a negative, so less than or equal to negative 18. So I have to decide if it's an and or an or before I make my two cases, because if I try to do it now, would it be or would it be and, because I've got both signs. So we look at the sign when it still has an absolute value to decide if it's and or. So this one is an or problem. We solve, we end up with 5 halves and negative 7 halves. So again, I'm wanting this to be true or this over here to be true. There's not an overlap. I'm not looking for both things happening. It doesn't have to be this and this. It has to be this over here or this over here. So when I graph it, we would expect the arrows to go in opposite directions. We're looking for values of x such that x are less than negative 7 halves or x is greater than or equal to 5 halves. And again, these have the equal to under them, so I have to include the dot. I have to show that it's including that by using a closed circle. If it's not including that, then we use the open circle. But if it's using it, including it, we use a closed circle. And my last example for the day, write and solve an absolute value inequality given a word problem. You can find out how much sleep you need by going to sleep without turning on an alarm. Once your sleep pattern has been stabilized, record the amount of time that you spend sleeping each night. The amount of time you sleep plus or minus 15 minutes is your sleep need. I don't want to do this. I think mine would probably be like 12 hours. I could go to bed every night at 7 and get up at 9 every day and be great. But that's neither here nor there. The amount of time you sleep plus or minus 15 minutes is your sleep need. Suppose you sleep 8.5 hours per night. Write and solve an inequality to represent your sleep need and graph the solution on the number line. So let's think about what it's talking about here. It says the difference between your actual sleep need and the amount of time that you sleep should be less than or equal to 15 minutes. So 8.5 hours is the central value, and 15 minutes, or 0.25 of an hour, think of it as 15 minutes out of an hour, 15 over 60 is 0.25, is the acceptable range. So the difference between your actual sleep and need or the actual sleep need is n. We're going to let n represent that. So n minus the actual amount, which is 8.5, is less than or equal to 0.25. So we've written our inequality now. Woohoo, we did good. Now what we need to do is solve it. So this is less than or equal to, less than, it's an and problem. So we're looking for solutions that meet this criteria and this criteria. We expect an overlap. So we add 8.5 to both sides, we get 8.75. Over here, they changed it to a greater than symbol because they made this negative. So since we made this negative, we had to change the direction of the symbol. Now we add 8.5 to both sides, we get 8.25. So this means that you need between 8.25 or 8 hours and 15 minutes and 8.75, which would be 8 hours and 45 minutes of sleep each night inclusively. We're including those values. You could get 8 hours and 15 minutes. You could get 8 hours and 45 minutes. It includes those numbers. So the solution set that represents the interval between two numbers, since it's less than or equal to and greater than or equal to, indicates that these are the solutions as well. So when I graph the endpoints, I've got to use solid dots to show that I'm including those. And then I shade the interval from 8.25 up to 8.75. All right, so you have an exit ticket that I would like for you to fill out. I am going to put a copy of this on Google Classroom with Cami, so I want you to type in your answers to this, and we will check them. I will check over them and give you 5 points for completing this assignment.